TCP/IP uses the IP address to uniquely identify each host on the network. The IP address is a layer 3 address, meaning that it is a logical address associated with the network layer. Let's look at the format for an IP address. An IP address is a series of 4 numbers separated by dots. Each number can range between 0 and 255. So a sample IP address might be 167.12.155.16. This is the decimal value of an IP address. IP addresses range from 0 to 255 because the IP address is a binary number. It is represented as a decimal number to make it much easier to work with, but computers use binary numbers. To understand how IP addresses work, let's learn how the binary numbering system works. Each position within the IP address is called an octet because it consists of 8 binary numbers. For example, the decimal number 12 is represented in binary as 00001100. An octet that is all zeros is equal to 0 in decimal notation, while an octet that is filled with 8 ones is the binary equivalent of 255 in a decimal number. That's why each octet within the IP address must range between 0 and 255. Let's convert between the decimal and binary forms of an IP address. To do this, memorize the decimal equivalent of each binary bit within an octet. For example, a 1 in this position equals a decimal 1. A 1 in the second position equals a decimal 2. The third position a decimal 4, and the fourth position a decimal 8. Each bit doubles the number that comes before. A 1 in these positions would equal 16, 32, 64, and 128. To convert a number to decimal from binary, such as 00001100, take the decimal values of each binary bit and add them together. If a bit has a binary value of 0, ignore it, because it also has a decimal value of 0. In this example, you add 8 and 4, ignoring all of the zeros, giving us the answer of 12. Let's try another example. 101001111, and convert this binary number to decimal. Add together the decimal value of each bit that has a binary value of 1. In this case, 128 plus 32 plus 4 plus 2 plus 1, equaling the decimal value of 167. To convert from decimal to binary, reverse the process. Look at the possible values and, working from the left, ask the question, will this number fit within the decimal value that I have? In this case, 128 fits within 155. So we put a 1 in the first position and then subtract 128 from 155, giving us a value of 27. We then go to the next position, 64, and ask the same question. Will 64 fit within 27? It won't, so put a 0. Next, is 32 smaller than 27? It's not, so put another 0. Next, will 16 fit into 27? It will, so put a 1 in that position and subtract 16, giving us a value of 11. Will 8 fit into 11? It does, so put a 1 here, now subtract 8, which gives a value of 3. 4, will that fit into 3? No, so that gets a 0. Finally, 2 fits into 3 and 1 fits into 1. So in this case, the decimal value of 155 converts into 1001111 binary. The IP address actually includes 2 different addresses, the subnet address and the host address. Part of the IP address identifies the subnet and the other part identifies the host. Where this division occurs is the function of the subnet mask. A subnet mask looks like an IP address. It has 4 octets. The subnet mask identifies which portion of the IP address is the subnet address and which is the host address. Wherever you see 255, you know that this octet is part of the network address. In this example, the subnet address is 167.12.0.0, while the host address indicated by zeros in the subnet mask is 155.16. You can have multiple hosts on the same subnet, and each host must have a different host address. All hosts on the same subnet share the same subnet address, but must have unique host addresses. Let's say that I modify the subnet mask to include 255 in the third octet. The subnet address is any octet that has a value of 255, which specifies a subnet address of 167.12.155. In this case, the host address is simply 16. To understand how a subnet mask works, let's convert the 255 into binary 11111111, or 8 ones. A subnet mask on a binary level simply means that the values have been set to 1 for each of these bit positions, giving us a decimal value of 255. It's possible to vary the subnet mask by inserting zeros instead of ones. That's called variable length subnetting, and we'll talk about that at a later time. A full octet of ones in the subnet mask is 255, which identifies this octet as part of the subnet address. Wherever you see 255 followed by a zero, that's the line between the subnet address and the host address. When configuring an IP address on a host, you must supply the subnet mask in addition to the IP address. IP addresses have a default subnet mask, which is identified by the address class. IP addresses are divided into classes, with each class having a different default IP subnet mask. If you see an IP address without a mask, and if the default mask is being used, you can determine the subnet mask by identifying the address class and using the default mask value. There are 5 IP address classes, A, B, C, D, and E. The IP addresses that fall into each class are identified by looking at the first octet in the IP address. If I had an IP address of 199.12.66.177, I can determine the IP address class by simply looking at the number in the first octet. The remaining numbers can be ignored for the purpose of identifying the address class. A Class A address in the first octet has a value between 1 and 126. The default subnet mask associated with Class A is 255.0.0.0. A Class B address has a value of 128 to 191. Its subnet mask is 255.255.0.0. A Class C address begins at 192 and goes up to 223, and its default subnet mask is 255.255.255.0. A Class A address has the first octet full in the subnet mask. A Class B address has the first and second octets full in the subnet mask. A Class C address has the third octet of the mask full. The other 2 address classes are used for special addresses and don't have a default subnet mask. Class D addresses are between 224 and 239, and Class E is 240 to 255. Class D addresses are called multicast addresses. A multicast address identifies multiple computers rather than a single host. And Class E addresses are experimental. Let's look at an IP address of 162.12.66.99. To find the address class, you look at the first octet and find the number range where the address fits. In this case, 162 lies between 128 and 191, so this is a Class B address. Class B subnet masks have 2 octets full in the subnet mask, so the default mask is 255.255.0.0. The first 2 octets are used for the network address, 162.12.0.0. The host address is 66.99. 191 and 192 is the boundary between Class B and Class C because of the binary form of the address. If we convert the first octet into binary, a Class A address begins with a 0 and is followed by 7 additional values. A Class B address begins with a single 1 followed by a 0, followed by 6 additional values, and a Class C address begins with 2 1s. As you work with IP addresses, it's important to be familiar with several special addresses. We have an IP address of 199.62.11.155. This is a Class C address because it falls within the range of 192 and 223. The default subnet mask is 255.255.255.0. The subnet address is 199.62.11.0. This address identifies the network or the subnet, and when you're assigning addresses to hosts, you do not assign the subnet address to the network host. Another special address is called the broadcast address. The broadcast address is the network address followed by a host portion of all ones, in this case 255. The broadcast address identifies all hosts on the subnet. If we had a network with 10 devices and we were to send a broadcast packet, all devices on that network would receive and process that packet. Suppose we have a network address of 160.22.0.0. This would be the subnet address. The broadcast address for this network is 160.22. We fill both octets with 1s on a binary level, giving us 255.255. You cannot assign the broadcast address to a host. If the network address is 199.62.11.0, the possible values we could assign to hosts on the network would be 199.62.11.1 all the way up to 199.62.11.254. You cannot assign the first address or the last address to hosts. In this Class B network, the host range would be 160.22.0.1 to 160.22.255.254. A Class A address is between 1 and 126, while a Class B address begins at 128 and goes to 191. 127 is skipped because it's another special address. The 127 address range is used to identify the local host. A common address you'll see is 127.0.0.1, which points to the local host. So if you use an address of 127.0.0.1, you are addressing the local computer system. That's it for this lesson. In this lesson, we discussed the construction of IP addresses, the binary nature of IP addresses, the role of the subnet mask, IP address classes and default subnet masks, and special IP addresses.